Okay, so Jane got the handouts. Jignasha, did you get the email with the handouts yet? Okay, might be away from the computer for a moment. Well, we'll go ahead and get started here. We're kind of light on people today, but hopefully more people will be logging in shortly. There we go. There's Caitlin. All right. So here's what we're looking at today. The first two topics kind of go hand in hand. The first one, we're going to take a look at the short reading comp passages that ask us to deal with the structure or the analysis of an author's argument. These questions in some ways are similar to reading comprehension, but in other ways are a little bit different because of the task that the questions set up for us. We'll also take a look at the second type of essay today, and that's the argument essay, and there is some overlap between the first two topics that we're going to deal with, because being able to analyze and understand an argument, which is necessary for the reading comp questions, is also really necessary for writing a good argument essay. And then finally, we'll take a little bit of a break after that, and then come back and spend the second half of class taking a look at math, specifically some very challenging word problems, mostly ones that happen to deal with things like probability, permutations, and combinations. But I think we'll also get a chance to look at overlapping sets as well. So some challenging topics, but hopefully by the end of today you guys are going to feel a lot more comfortable. These are topics that are challenging because they are not necessarily as intuitive, at least at first glance, as other types of math, but usually the math underlying them is actually not that bad. So if you can get good at these, it gives you a chance to really, really be able to handle some more difficult questions. But let's go ahead and dive right into our argument stuff. So this is a type of question that is brand new to the GRE, or at least new to the new GRE. Basically, questions like these showed up on the previous version of the test back in the mid-90s. And then in 1998, they got rid of these. And for the last 13 years or so, they have not included questions like this. But with the coming of the new test in August, which is, wow, just a few days away, tomorrow actually, come to think of it, they are reintroducing this question type. But they're not really giving it its own section. Instead, what they're doing, which I think is very interesting, is they're mixing it in with the reading comprehension stuff. So the characteristics of these types of problems is that you're only really going to get a very short passage compared to the other reading comp passages. So somewhere on the order of 3 or 4 sentences, maybe at most, basically a paragraph, and you're really only going to get one question per passage instead of 2 or 3 of them. You're going to see a couple of these per section, so between the 2 sections, maybe somewhere between 4 and 6 of these. And the important point to make is that this is not really reading comp anymore. Even though you're reading a passage to gain the information you need to answer the question, what they're really testing you on more is the underlying logic in the passage and less about the details or the facts. So that's something that we need to keep in mind. There's a couple of common question types. They oftentimes ask us to do things like weaken or strengthen an argument. Sometimes they ask us to resolve a paradox, which is a very strange type of question, but we'll take a look at that in a minute. Sometimes they ask us to discuss the structure of an argument. And in addition to that, they'll often ask us to draw a conclusion or draw an inference. And that's the type of question that's actually pretty similar to the reading comp, at least the reading comp questions that ask us to infer something. So our approach is going to be a little bit different than what our approach is for reading comp. There's a lot less text to read. So it's a lot less about trying to get the big picture and ignoring the details, and more about trying to understand how each of the different parts of the argument fits together. whether that's an argument that has a main point supported by a series of factual premises, or whether that's an argument that gives us 2 or 3 facts and asks us to infer on the basis of them. Our goal is going to be to really understand how those pieces fit together, how they work as a whole to create whatever message the argument is presenting. So we're going to have a basic sort of approach here that starts out with us previewing the question. In other words, we want to, even before we read the passage, we want to have a really, really good idea what our goal is, what our task is, because that will affect how we read it. We want to be able to break the argument down, understand its component pieces, and ideally anticipate an answer. Now, that doesn't mean we're going to be able to predict word for word what the answer is going to be. In most cases, we're not even going to come all that close. But we should be able to anticipate what type of answer, what sort of answer would work, given the goal that we've been given in the question. And finally, we want to use process of elimination really, really well. Very, very important that we don't simply pick an answer because it strikes our fancy. Very important that we pick an answer only because we're sure that the other 4 are wrong. This is also, of course, important on reading count, but I think it's most important with these sorts of questions because oftentimes the difference between 2 answers will be very, very minor. It'll be 1 word or the meaning of 1 little phrase. And recognizing in the end that one of those is wrong is really what allows us to recognize that the other one is going to be correct. All right, so any questions so far? I know we're talking in vague generalities. We'll take a look at a question next, but just want to make sure that you guys are comfortable with the overall idea. All right, sounds good. So let's take a look at one of these. First type of question that we're going to look at are the questions that ask us to draw a conclusion. And the reason why we're doing these first is these are the ones that are most similar to what appears in the reading column. Specifically, these are similar to what we're calling inference questions in reading column. So remember those inference questions that we did previously, the ones where we had to be able to read the passage, we had to be able to identify an important fact or facts, and we had to be able to come up with another thing that was true on the basis of what was stated in the passage. And it wasn't something that was out of left field. It was something very close to the passage, even if it wasn't directly stated. Well, that's the exact same idea here. So I want to give you guys about a minute to read this argument about neoprene. Nephroprene. I'm mispronouncing it already, so nephroprene. Read that, and all I want you guys to do is to think about what the facts are saying, and think about what else might be true given these facts. Not what else is possible, but what else is true given these facts. So here we go, 1 minute. Okay, so you guys think that you've got this down pretty good? When you're facing questions like this, what you really want to be able to do is to read the passage, recognize that this is not a true argument like some of the ones we're going to look at in a few minutes because there's a lack of an author's main point. This is more a series of facts. And we want to be able to separate them and summarize them. So you guys tell me in very shorthand, what have we learned about this drug, nephroprene? Okay, so number 1, we've got these benefits, and they tell us these benefits, but they also tell us that we've got side effects, and those side effects are maybe worse than the medical problems in the first place, right? Although they don't actually say, they just say they have serious side effects. So be careful a little bit there. They didn't actually tell us the side effects are worse than the benefits for curing the harmful medical conditions. Okay, so Jane's telling us that most doctors will not prescribe it. What else? What else do we have here that seems important? Do they give us any explanation for why doctors might not prescribe it? Yeah, and Jane and Caitlin are giving me two different answers, but I think collectively they've summarized it really well, right? They're responsible for weighing the benefits and possible harms, so there's some sort of responsibility to the patient. So where would we be on our actual paper? We might have something like this, right? We might have something like this on our paper, and let me explain what's going on here. So the logic here is that we've got this kind of a T-bar that we've drawn on our paper. And what we're going to do is we're going to write the conclusion of the argument up here. Well, this argument doesn't have an actual conclusion. We'll see some in a little bit that do. This argument is just a series of facts. So we're going to write those facts down over here in the left column. The reason why we've got a right column here is that we would want to be able to write down any countering evidence if it appeared. In this case, there's not really any countering evidence, but oftentimes an argument will have both the author's side and an additional opposite side, and oftentimes we want to be able to note on the other side what the opposite viewpoint is. So in this case, we don't have a conclusion that we've written up here because we have to come up with the conclusion on the basis of this. So let's do that. What do you guys think you could conclude based on these facts? Based on these facts, what could you conclude about the world? And remember, we don't want to just make stuff up. We don't want to go out into left field here. Instead, what we want to do is really pay close attention to the facts as stated and use those facts to infer another fact that is not that much beyond it, right? Maybe it's not directly stated, but it's nevertheless very true. So what do you guys think? What do these facts support? And Jane, I love how you put that. You didn't say the side effects outweigh the benefits in reality. You said the doctors think that. We don't actually know. We don't actually know very well the truth of this. We're not the scientists investigating this, but we can infer what the doctors think. So I love the way Jane put that, and that's potentially the difference between a right answer and a wrong answer, right? So docs think that the side effects outweigh the benefits. I love the way that Jane put that. Think about an answer that simply said the drug nifopramine has worse side effects than the benefit gained from taking the drug. We don't actually know that. We just know what the doctors think about the drug. We do know that the drug has side effects, but we don't actually know how to compare it. But I love the answer about what the doctors think. Is there anything else you guys would say we can infer here? All right, well, in that case, we've done a good job. Here's what we've done. We've previewed the question and realized that it's asking us to draw an inference. We've notated the different facts in the passage really, really well. We've made sure that we didn't add any information that's not actually there. We've stuck very, very close to the actual text of the passage, but we've summarized it in a way that makes it easier to think about. So that's the thing. We want to be able to summarize in a way that makes it easier for us to think about all of this at once. But we don't want to summarize it in a way that ends up deleting or ignoring or overstating what's actually in the passage. And finally, we anticipated the answer, and as you guys will see on the next screen, we anticipated it pretty well. So let's take a look at the answers. Our last step is always going to be to eliminate the wrong answer. So let's start with A. Nifopramine will not cure patients. Can I conclude that? Okay, most doctors have determined that the side effects of nifopramine outweigh the benefits. Can I conclude that? Okay, so should I just circle this answer and move on to the next question? Yeah, I got to look at all five. Really, really important that I look at all five. Okay, patients who want to take nephroprene are not able to obtain prescriptions for it. Yeah, that's a keeper as well, because if the doctors aren't prescribing it, then that means that the patients can't get prescriptions for it. That's a definite, well, definite maybe, which is oxymoronic, but that's okay. You guys will forgive me. Let's see, D, not all patients with medical conditions that can be helped by nephroprene will actually experience benefits. Do we know the patients aren't going to experience benefit? It's not whether they're going to experience benefits, it's whether the benefits are enough to make up for the serious side effects. Okay, and finally, E, the doctors who decline to prescribe nephroprene are not fulfilling their duties as doctors. Yeah, these answers that make bold claims about an entire profession, right? We just don't have support for that. We don't have support for the idea that they're not fulfilling an obligation. The argument actually says they have an obligation to, make good choices for their patients. So if anything, it appears they are fulfilling an obligation. Of course, this is Ian turning on the cynical button. We all know that in reality, whether or not nephroprene gets prescribed has everything to do with whether the doctors have been given money and or trips by the manufacturer of nephroprene, but that's me being cynical. Okay, B and C, we've kept both. Both make kind of sense, right? So you guys tell me. I don't want to know which of these two is correct. Although one of them's fairly close to what Jane predicted, I'm not going to pick B simply because it matches what we predicted. I'm only going to pick B if I know why C is wrong. And if I don't know why C is wrong, I have to really seriously consider whether B is actually wrong. So you guys tell me, give me an argument for why one of these two is incorrect. Okay, so why is B wrong then, Jignasha? Okay. I mean, to some extent I'll buy that, except for the fact that that's the way these questions often work. We can't make stuff up, but we are allowed to infer things that aren't directly stated as long as the evidence in the passage guarantees that they must be true. There you go, Jane, you've got it. Most doctors have chosen not to prescribe it. Does that mean patients will not, right? They don't say most patients. They don't say will have a hard time obtaining it. They say patients will not be able to obtain it. C is making a statement of absolutism. It's saying that patients can never get this drug. But it's possible that they can get the drug if they find some doctors who have chosen to prescribe it. If I say most do not do something, I'm implying that some do it. And in that case, that means that that C is incorrect because of that word, most. And B is a good answer. There's nothing wrong with B. We can infer that the doctors have determined that the side effects outweigh the benefits. Now notice that if they left out the middle portion of this argument, we would not be able to infer B. So let me give you an example of what I mean by that. Let's say that they had left out this part. Let's say they'd left out all of this. All they said was nephroprene has been proven to help certain harmful medical conditions, but also has serious side effects. Most doctors have chosen not to prescribe nephroprene. In that case, I would not be able to pick B because all I know is the doctors have decided not to prescribe the drug. I don't know why the doctors have decided not to prescribe the drug. Just because it has serious side effects and most doctors have chosen not to prescribe it, that does not guarantee that those two facts are related, right? It's entirely possible that the reason they've chosen not to prescribe it has nothing to do with the side effects. But once I'm given this information about why doctors, what their responsibility is, and why they choose to do things, now I have a connection between these facts, and I've got enough of a connection that I'm able to infer that most doctors are making this choice because they're determining, not because it actually is, but because they think it outweighs the benefits. All right, questions? Jignash, are you happy with that? Why we got rid of C in the end? Does that make sense? Okay, cool. So watch out for these. The answer doesn't necessarily have to come directly word for word from the passage, but it has to come from something pretty close to what's in the passage. In other words, I could not make an argument, I cannot make an answer that was making a prediction, let's say, about what doctors will do in the future or something like that, no matter how likely that is to be true, at least given this argument. But I can say B is correct because they've given me enough facts to support it very strongly. So this is the question type that is most similar to the reading comprehension. But I want to look at another question type next, a question type that's not very similar to reading comp, but is similar in one way in that it does not contain a conclusion. Does not contain a conclusion. It's simply a series of facts. But now they're going to ask us to do something different with these facts. So let's take a look at this. We call these questions resolve a paradox because they often use that phrasing in the question. So as always, let's preview the question. Which of the following, if true, would help to resolve the apparent paradox? So the words that you're looking for here are words like explain, resolve, solve, the paradox, contradiction, problem, I'm running out of words here, mystery, enigma, riddle, right? So that's how they're going to phrase these. They're going to ask you to solve, resolve, or explain a paradox, a contradiction, a problem, a mystery, an enigma, a riddle. And every time you get one of these, they're going to work the same way. The passage is going to present to you two facts that seem to contradict each other. And your job is to pick an answer that explains how these facts are not actually contradictory, how these facts actually work together. So let's take a look at this. In 2008, the government of Province X reported 350,000 residents living in poverty. Between 2008 and 2009, the population of Province X dropped slightly, and the average income increased slightly, while the distribution of income over the population remained relatively constant. Yet, in 2009, the government of Province X reported a sharp increase in the number of residents living in poverty. So, all right, so we want to be able, now that you guys have had a second to kind of let this sink in and think about it, we want to be able to list out the facts, right? So we'll make one of our diagrams here. We want to be able to list out the facts, notate them on our paper, but we also want to be able to take the next step and recognize where there's a contradiction. So you guys tell me, what facts are in this? Okay, that's the first one. Government reported this number. Yeah, maybe I'll add that because that might be important, that it's a government report. Does that mean that's the actual number of people in poverty? We don't know, right? Okay, so in 2009, and this I think is important, it's actually a sharp increase. 2009 equals many more in poverty. Okay, so at first glance, those two statements don't contradict each other because it's possible that a lot of people became poorer in the intervening year. So what other facts do we have that create this sort of contradiction? What do you guys think? What other facts do we have? Okay, so the population decreased slightly, income increased, and there's one more thing. There's one more thing, because you can have, and this is what's happening, by the way, in the U.S. right now, you can have average income go up, but have some people get a lot poorer if the income increase was due to the richest getting much richer. Right? In the last 20 or 30 years in the U.S., average income's gone way up, but that average is going up simply because the people at the very top are increasing a lot. All right, so income distribution remained constant. Okay, so I think the easiest way to do these is to get the facts listed and then to figure out how to phrase a question, like a why question, that makes it really clear what the paradox is. And in this case, what I've done is I've written everything in blue except for the point that diverges. So how could I phrase a question that would make it really clear what the paradox is that I'm attempting to resolve? Yeah, Caitlin, I think I agree with you. I think that's a really good way to put it. So why was there more people in poverty when the population decreased and income increased, and by the way, distribution stayed the same, right? And so these are the notes that I might take when I'm looking at this problem. So what do you guys think? What are some ways that we could end up having this happen? How could the population go down a bit, income increase a bit, and yet more people end up in poverty? So Caitlin's saying maybe the answer is simply that they changed the definition of poverty. That makes sense. What else? Yeah, but Jignasha, there's a problem with migration. What's the problem with migration being the answer? What do you guys think is the problem with that? Because that in a lot of ways makes a lot of sense, but in this version there's actually a problem with that. Right, we would know something about the population increasing if it had to do with migration. And they've told us that the population decreased slightly. So we don't want to pick an answer that goes against any of the facts stated. We have to accept that the government reported 350K in 2008, that the population in the intervening year decreased slightly, that income increased, that income distribution remained constant, but yet in 2009 there were many more people in poverty. So I think we've got two good ideas here, right? Caitlin's saying that maybe we've changed the definition of poverty, and Jane's saying that maybe the government lied. Or maybe lied is too strong a word, but the government got the figure wrong. That happens all the time, right? The government says one thing, and then a year later you discover that their numbers were incorrect because they do a better census or something like that. So we've done our steps. We've previewed the question. We've broken down the argument and really understood it very well. We've anticipated the answer. That doesn't mean we've predicted word for word what it's going to be, but we've anticipated what type of answer we're looking for. So I think we're now good to look at the answer choices. And when we look at the answer choices, let's refer back to this question that we came up with. Let's ask ourselves, does this answer help me answer the question why there's more poverty in 2009 even though these other things happened? So let's ask about A. In province X, in years prior to 2008, the poverty rate rose steadily. Does that answer the question why there was more poverty in 2009? Why not? All right, I'm going to make life harder on you guys. You can't just tell me no anymore. You got to tell me why. Jane, hop on the mic. Tell me why. Tell me why for A.
Well, it says nothing about this particular year between 2008 and 2009, which is what we are concerned with, and also doesn't say anything about like income level, population, or any of the other factors that we're considering.
Okay, yeah, it's out of scope. The argument's about the change from 08 to 09. We don't care about this other stuff, just like you said. Okay, how about B? Would B tell us why there was more poverty? Yeah, I agree with you guys. Now, that's not one we predicted, but it sure as hell makes sense to me. Let's hold on to that. Okay, let's look at C. In 2009, due to changing tax legislation, many companies in X discontinued certain benefits to residents of the province. Got to vote for maybe. I mean, yeah, it doesn't, well, but the population decrease is more a fact. It's not the actual paradox, right? The paradox is that the poverty went up in spite of the population decrease. Does C tell us why poverty might increase even if, yeah, exactly. And it's the same thing in B. Unless you assume that people died in the natural disasters, B doesn't really tell us anything about the population decrease either. It's more about, could it be possible that an answer like C, yeah, Jane, maybe that even though the income went up, people may be paying more, and so that their poverty has actually gone up. Even though they seem to have more disposable income, they really don't, because they're spending more of their money on benefits they used to get for free. I think that makes sense. Okay, let's take a look at D. In 2009, the government of province X changed its definition of poverty, thus changing the status of some residents. That's actually pretty close to what Caitlin said originally. Is this worth keeping? What do you guys think? Is D worth keeping, or is there a reason to eliminate it? Okay, are you guys getting worried at all that we've kept 3 answers so far? Don't be, and I'm being totally serious about that. I think it's actually a great thing that we've kept 3 answers. It means that we're open to the idea that the answer might be something we haven't previously considered. I oftentimes end up keeping 2 or 3 answers on my first pass. What you want to do is take 2 passes through the answers. Get rid of the answers that are obviously wrong, and that gives you more freedom and time to carefully consider the remaining answers. But let's take a look at E. Between 2009 and 2010, the number of residents living in poverty dropped back to 2008. Jignasha, tell me why. Hop on the mic and tell me why E is wrong. Okay, just type it in then. There we go. We're back to the wrong time period. E is attempting to explain something they haven't asked us to explain. Problematic. Okay. So B, C, and D are our remaining answers. It's actually interesting that D is the answer that we somewhat predicted ahead of time. But that doesn't necessarily mean it's the right answer, especially if it says something a little bit different than what we predicted. In this case, it's pretty close. But what we want to do at this point is compare the remaining answers and figure out which two are wrong. And there are two out of this group, although all three are close. One of them actually works well, and the other two don't quite get over that hurdle. So tell me why some of these answers are wrong. I don't care which one's right. I want to know which two are wrong. Wow, I'm just getting a wall of silence from you guys. Well, I've got a problem with that, because where does B say that the population decreased between 2008 and 2000? Oh, whereas here it says during 2009. I see what you're saying. But I guess my question is, do we really care about the population decrease? What we care about is that in 2009, there was a sharp increase in poverty. Does B explain how there could be a sharp increase in poverty in 2009? That's the real question. Okay, think like the test writer. Don't pull your own biases in. Don't make your own assumptions about how the world works. Simply focus on the facts in the passage. In answer choice B, do you know that natural disasters make people poorer? Well, this is where things get difficult, Jane. You're supposed to only use stuff from the passage, only info from the passage, but you have to be able to think about what the passage is implying. So in other words, and I'll just give away answer choice B, if B had said several natural disasters struck Province X during 2009, forcing many people into poverty because of the destruction of their home. They didn't say that. Is it possible to have a natural disaster and not really have people become poor as a result? I mean, if everybody has insurance, yeah, it was a tragedy, but does that mean that they actually went into poverty because of those natural disasters? For all we know, Province X has natural disasters every year. Maybe they had a natural disaster in 2008 and 2007, and that's just part of, yeah. So basically, we're not allowed to infer, or maybe the better word here is we can't assume that a natural disaster increases poverty. They didn't tell us that. They didn't make it clear. Whereas in D, they're very specifically talking about poverty. And I kind of gave it away because answer choice B is really similar to answer choice C as well in the end, right? Unless they came along and actually told us, right? Unless they came along and actually told us that the discontinued certain benefits led to poverty, then we've got a problem with this answer. It doesn't really help us. Does that make sense to everybody? So it's about not making assumptions to make the answer work. That doesn't mean you will never need to rely on some common sense real world knowledge. But it can never be the core of the answer. The core of the answer should be straight out of the argument itself. And in this case, since the argument was about poverty, answer choice D gives us an answer exactly about what happened to poverty and does it really, really well. In fact, that's what Caitlin predicted ahead of time. So it's actually a great answer, whereas in B and C we have to make additional assumptions about how these could have an effect on poverty before we can make them work. If you've got to think about how an answer, if you got to think about what you would additionally have to assume about the world to make an answer work, it's probably traveled too far away from the actual passage. All right, tricky one, right? I'm glad we kept B, C, and D on our first pass because B and C are really, really close. You could change those answers with just the addition of a word or two and they'd be correct. But what I want you guys to notice is that when we got down to the last three, B and C are very similar. They're very similar. And they can't both be right. So they got to both be wrong would be another way to look at it. So Caitlin, should it mention cause and effect in the answer? In this case, I think we needed, if not cause and effect, at least some explanation that tied back into the poverty. But keep in mind that the next problem you look at might not be as much of a cause and effect type argument. And if it's not as much of a cause and effect type argument, you might not actually need an answer that was cause and effect. But in this case, D so clearly brings the poverty back into the answer that it makes it clearer how it's possible to have an increase in poverty even though income increased and population decreased. Yeah, exactly. This sort of help resolve, right? What's going to help us explain how these facts can be true, even though they appear to be a paradox? How can we help resolve it? How can we help fix it? How can we help understand how these go together, actually? All right, you guys ready for another question type or more questions about that one? Yeah, and Liz is totally correct. So let's look at this next question now, and let's really think about exactly what this question is asking us. So the next one, if you guys look at it, which one of the following statements, if true, directly contradicts the information presented above? Think about this as kind of like that draw a conclusion question, but in reverse. Instead of picking the answer that's guaranteed to be true given the facts, you're looking for the answer that is guaranteed to be false, that cannot be true given these facts. So let's look at the facts. Between 55 and 85, number of women who considered themselves self-employed rose, but at a lower rate, interesting, than the number of women participating in conventional full-time employment. So we're looking for something that contradicts that. So you guys tell me, what are the facts here? What should we note in our little notation system? So what do you guys think? Are they talking about a real number or a percentage number here in this first part? So Jignash, are you sure about that? What if there was one woman in 1955 who had full-time employment and there were 50 million self-employed women? And then the rate could increase much quicker for full-time employment, but we might still have less total. Does that make sense to everybody? So this first statement is about a real number. What's the second statement about? Yeah, so I think those are our two statements. The number of self-employed women increased. That's a raw number. That's a total number. but the rate of increase was less than the rate for the full-time employment. Everybody feel comfortable about that, about those two statements? Now, in this case, we want to anticipate an answer, but it's going to be hard to predict it very well. And the reason why is because we're being asked what cannot be true, what contradicts the information. There's a lot of things that can contradict that information, so it's going to be hard to predict it. But we know the answer, we can anticipate the answer is going to fall somewhere on the line about actual numbers of women and the rate of the increase in the number of women in these different roles. And I can probably guess that the incorrect answers are going to play on a misunderstanding of real numbers versus rate numbers. So let's be careful about that. But let's go ahead and look at the answers now. Let's take a look at the answers now. So from 1955 to 1985, the number of women who considered themselves self-employed increased from 3 to 6.5, while the number in conventional full-time employment increased from 25 to 46. Does that contradict the information above? Okay, I've got 2 yeses and a no, I mean yes, so I'm going to take that as 3 yeses. What does it contradict? What part of the argument does it contradict, guys? Yeah, so given this answer, what's the rate of increase for self-employed? Oh yeah, more than over 50%. No, it's actually greater than 100%, right? Because it's an increase, right? So yeah, so it's actually doubled. It's more than doubled. So it's like 200%, more than 200% of the number in 1955, but it's an increase that's a little bit bigger than 100%. From 25, so maybe it's simpler to just say greater than doubling. How about for the other group? Is it more than doubling? Yeah, it almost doubled. So don't you guys love this? We're doing math on the verbal side, right? We're doing math on the verbal side. Okay, but let's keep going. So answer choice B, during the period in question, the overall labor force decreased in number. Remember, we're always going to look at all 5. Do we care about the overall labor force decreasing? Is it possible for women in the workplace to increase a lot, but yet the overall workforce decrease? Is that possible? Yeah, if a lot of men stopped working, absolutely. All right, how about in 1985, more women worked in full-time employment than considered themselves self-employed? Do we know the actual number comparison between full-time and self-employed? Yeah, we don't know this because we don't know the starting numbers. If you start small and increase quickly, you might still end up smaller than something that starts big and increases slower. We'd have to know the starting point to know whether or not the total number in 85 was bigger for full-time employment. Okay, how about D? The number participating in 1985 in part-time employment was even higher than the number of women participating in full-time employment. What do you guys think? Isn't C pretty much the same as D but in reverse? Either way, we can't know whether this contradicts the argument because we have no idea what the starting number is. And finally, number of women who considered themselves self-employed in 85 was higher than the number participating in full-time employment in 55. So now we're comparing the actual number in 85 in one category to the actual number in 55 in the other category. Do we know that that contradicts the information above? Okay, dead silence from the room. Let me just ask you guys this. Can I compare the actual number of one group in 85 to the actual number of the other group in 55? No, even though one group has increased in the intervening 30 years, we don't know where it started. We don't know whether it started bigger or smaller than the other group. So we can't say anything about, we just don't know this fact. It might contradict the passage, but it might not. We just don't know because we don't know the starting positions. All right, so we like A, right? Good answer? All right, so good job, guys. So here we go. On to the next kind of question. These questions are interesting because what they do is they give us a highlighted portion, and then they're going to ask us to understand the role that they play. Here's what's really important. The first three types of questions we looked at really weren't arguments in the purest sense of the word. What I mean by that is they were not true arguments that had an author's main point supported with different pieces of evidence. But this kind of question really is a true argument. This really is an author's conclusion somewhere in there that's supported by different facts. So we need to be able to recognize that structure. We need to be able to think about what role is being played. And the way to do that is to try to figure out what each of the parts of the argument is. So let's take notes. You guys read that argument. I'll give you a minute to take a look at it. And then I want you to tell me what the author's conclusion is, what supports that, all of that good stuff. So you guys tell me. Everybody got a chance to read it? Keep reading if you haven't, that's okay. I just want to know, what does the author want us to believe about the world? All right, so Jane, you'd call that the author's conclusion? And I'd agree with that. And the way that we tell whether something is a conclusion or not is, number one, it needs to be an opinion. And number two, it needs to be supported with the rest of the information in the argument. And if you're ever confused about whether something is a conclusion or not, ask yourself, when I'm done reading this, what's the biggest claim? What is the final thing the author wants me to believe? So we're going to say skydiving does not equal cardiovascular exercise. That's our conclusion. So let's list out the evidence for that. And I think that we want to list out the evidence in order. Not necessarily the order it appears in the argument, but the logical order. How do we get from skydiving and what it is all the way to skydiving is not cardiovascular exercise? You guys tell me. Summarize it. List it out step by step. Okay, so cardiovascular exercise is equals, right? Elevate the heart rate. And if I could draw a heart, I would, but I can't. So the heart rate, for, at least 20 minutes, right? Sorry for my horrible handwriting here. Let me move this over and give myself a little bit more room. Okay, we need it for it to elevate our heart rate for at least 20 minutes. Okay, so greater than or equal to 20 minutes. Okay, what does skydiving do? We still haven't proved, okay, so skydiving equals an increased heart rate. And even tell us it increases the heart rate, for around 1 minute. And then there's one final part, because if you increase your heart rate for 1 minute and then do it over and over and over again, you might still be cardiovascular. Okay, so skydiving is not back-to-back. All right, so here's what I want to do. Tell me then, we've been given this question that asks us what the roles of these are. Let me highlight what's actually highlighted. So that's highlighted, and that's highlighted. So you guys tell me, what's the role of the first highlighted portion? Okay, and what's the purpose of the second part? What's the purpose of the second part? What does the second highlighted portion do? Yeah, it simply supports the conclusion. Okay, here's how to do these questions really quick and effective. I'm going to show you guys the answers now. Start with whichever one's easier to work with. In this case, we know the first one's the conclusion. Eliminated any answer that doesn't say the first part's the conclusion. What can I eliminate? C says the first one support for the conclusion, not the conclusion itself. What else? Caitlin's saying A, B, and C. So B says the first states a position that the argument opposes. That's wrong. A says intermediate conclusion. That's interesting, intermediate conclusion. But notice what they continue to say, that supports a further conclusion. Well, that's wrong, right? It's not supporting a further conclusion. It's the final conclusion. Okay, take a look at answer choices D and E. D and E just say the first gives the main point, the first states the conclusion. That means the same thing. Main point, conclusion means the same thing. We got to keep both. So now we look at the second. We want to eliminate the answer that doesn't say it supports. Which one does not correctly identify the second portion as supporting the argument? Yeah, D is out. Supporting a position, we like it. That's great. The author opposes. Now it's wrong. And that's going to give us E. Notice what happens in answer choice D, though. Can you see how someone might pick D? Why might somebody pick D here? Maybe word evidence, but evidence is is fine. I guess what I was getting at is what makes D wrong comes at the very end. The second provides evidence supporting the conclusion. That's correct. But supporting a position the author opposes, it's really not until the last two words that we get to the reason why D is wrong. So lots of times people only partially read these answers. They see stuff they like at the beginning of an answer and they go with it. Lots of times the jury will bury something that makes an answer wrong all the way at the end of the answer. You got to read not just every answer, but every word in every answer. You got to make sure that you've got it figured out. Okay, so questions at all about this question type? So what I want you guys to take away from this is both how to do this kind of question, but I also want you guys to see that we have a true argument here. We've got a conclusion supported by evidence. That's really important because the next question type we're going to look at does the same thing. It asks us to weaken the argument above. So when we're asked to weaken an argument, what we really want to do is not weaken it directly. Like, let's say the argument is, this is a great plan to save the city a lot of money. Think about how dumb it would be if the answer was simply, this is not a great plan. So they're never going to give us an answer that directly contradicts the conclusion or even directly contradicts one of the pieces of supporting evidence. Instead, what they're going to do is they're going to attack the connection between the evidence and the conclusion. So in this case, I want you guys to read this argument, and all I want to know is what is the author's conclusion and why. What evidence supports the conclusion? So what's the conclusion here? You guys tell me, what is the author trying to make us believe about the world? Crickets chirping, no one's talking. Okay, ostriches will inevitably become extinct. Let's keep life really simple. Let's keep life really simple, one step at a time. The conclusion is the ostriches will inevitably become extinct. How strong a conclusion is that? Is that a weak conclusion or a very strong conclusion? We have a disagreement. Yeah, Jane, it's a very inevitably become extinct. That's very strong. Not might become extinct, not at risk of becoming extinct, but inevitably. So what evidence shows us that they will inevitably become extinct? Okay, just because they're endangered species, that doesn't do anything for us. But if we add that to is becoming popular in the U.S. Now notice what I am not highlighting in the passage. Ostrich meat, which is low in fat and cholesterol. Okay, that tells me why it's becoming popular. But does that actually matter to the argument why it's popular? If I'm really just trying to say that ostriches are going to become extinct, do I need to know why they're popular? Yeah, it's actually not important to know why it's popular. Try to simplify an argument like this. This argument is saying in the end, ostrich is becoming popular. It's endangered. Therefore, if the popularity increases, they're going to go extinct. It's a very simple argument. Now, what we're trying to weaken here isn't whether or not ostriches will become extinct. At least we're not weakening that directly. We're trying to weaken that by chipping away the connection between the evidence and the conclusion. So you guys tell me, given that it's becoming more popular and that ostriches right now are an endangered species, does that prove it's inevitably going to go extinct if people eat more and more of it? Are there any other possibilities? We eat a lot of cattle. Does that mean cattle are going extinct? But they're not endangered. Okay, that's a good point. That's a good point. So what are we assuming to be able to say that they're endangered? If they get any more popular, they're going to go extinct. What are we assuming here? Okay, maybe we have to assume that they're not reproducing. So a way to weaken this would be to say that ostriches could reproduce at a faster rate to offset the popularity in their meat. Notice how we weaken it. Okay, the rate of production remains constant. Yeah, that's a good point too. I think Jane and Jignash are saying similar things in slightly different ways, right? We have to assume that in the future there's not going to increase the rate of production of ostriches to offset this additional meat consumption. Great. Well, if we have to assume that, that's what we want to attack. That's what we want to attack to weaken the argument. Okay, so let's take a look at this. Ostrich meat is not any healthier than lean beef, which is available everywhere and less expensive. Does that weaken the argument? Why isn't it relevant? Doesn't that show us that people are going to eat beef instead of ostrich? Okay, no mention of beef, but let's be careful. Sometimes the answers to these sorts of questions can be, at least at first glance, appear to be out of left field. So it isn't whether or not the original argument mentioned beef, it's whether beef weakens the argument. Jane, very good point. Here's what I want you guys to see. Answer choice A doesn't attack the argument. Answer choice A contradicts a statement in the passage, not the statement about healthy. It may or may not be healthier than lean beef. But answer choice A attacks the statement that it's becoming popular in the U.S., right? A is weakening it by showing that people aren't going to be eating a lot of ostrich. But the argument is about eating ostrich. They're already telling us people are going to do that, and if they do it, it's going to go extinct. So this answer is attacking a premise, or in this case premises, instead of attacking the core of the argument. Okay, how about ostrich meat is considered by many to be a gourmet food, suitable only for special occasions? All right, I saw typing and then everybody gave up. We're never going to get through this lesson if you guys don't answer these questions. All right, why not? Caitlin, hop on the mic.
Because it doesn't really explain, well, when people are concerned with the health and the dieting, I think that they would not be worried about the special occasions. That would be every day.
Yep, answer choice B is exactly like A. What it's attacking is that it's becoming more and more popular, right? It doesn't really get to the heart of whether or not the ostriches are going to become extinct or not. Okay, how about C? Concerns about avian flu, although spurious, have caused many consumers to avoid ostrich meat. Jignash is saying no. What's answer choice C like? It's still attacking the idea about whether they're getting more popular, whether people are going to eat them. Okay, how about D? An increased demand for ostrich meat will lead to increased ostrich farming, thus increasing the number of ostriches. All right, we got to vote for yes here. Okay, and finally E, ostriches are killed far more frequently. Ostriches are killed far more frequently for their feathers and for the making of leather than they are for meat. Does that weaken the argument? Yeah, if anything, it strengthens it. It makes it worse for the ostriches because if we're not just killing them for their meat, but we're also killing them for feathers and leather, then that makes it even worse. Look at how D works. Farming. Did they mention farming in the original argument? Notice what they said. Which of the following, if true, most seriously weakens the argument? So the answer might bring up new information for this question. That's a no-no in a lot of other question types. But in this question, the answer might bring up new information. The question is, would that new information weaken the argument? Remember, we're not trying to directly attack the evidence. We're not even trying to directly attack the conclusion. I mean, it would be correct to weaken the argument to say ostriches will not become extinct, but they're never going to actually do that on the test. That's way too simplistic. Instead, what they're going to ask us to do is pick an answer that attacks the connection between the evidence and the conclusion. And in this case, we're assuming that ostriches are endangered today. We're assuming that they won't increase the number of ostriches in the future, that they'll remain endangered. We have to assume that. Notice they never said they will remain endangered in the future. They just said they're endangered now. And so we've attacked that idea by saying, hey, we're going to start farming them. And if we start farming them, then they're not necessarily going to go extinct. It severs the link between the evidence and the conclusion. That's what we're looking to do. Questions about this at all? All right, folks, I got one more question for you. I'm going to let you guys do it yourself. Take 2 minutes, read the question carefully before you try to figure out how to answer it. Make sure you know what the question's asking you to do. Here you go. Okay, I've got 2 answers in so far. This is an extremely difficult question, actually. Um, sorry to hit you guys with a tough one to end things, but it's actually shows us something really important. Shows us something really important. In this problem, before we dive into it, I just want to know what the conclusion is. Just tell me, first sentence or last sentence, which one's the conclusion? All right, so we've got diet and care has declined in the last 15 years. What tells us that? What's the evidence that the diet and the care has declined in the last 15 years? I'm just going to use red for conclusion and blue for evidence. What kind of evidence do we have? Okay, and fatal heart murmurs. Okay, so where do we get these? Whoops, I've totally screwed up my colors here. My apologies. Let's start over with this. Okay, there we go. So more fatal murmurs in puppies than there are in dogs over 15 years old. Okay, so what we're really saying is if we look at the rate, the incidence of heart murmurs in puppies, it's higher than the incidence of in 15-year-old or older dogs. What do you say? Is that good evidence? Does that prove our conclusion about how care for dogs has gotten worse in the last few years? Jignash is saying that's not very good evidence. I agree with you. It really isn't. What are we really comparing when we compare puppies to old dogs? Are we actually comparing what's happened in the last 15 years, or are we comparing 2 very different populations? That's a problem here. That's a problem here. All right, I'm going to give you guys an analogous argument. Let me ask you a question. In the last 100 years in the United States, the average life expectancy of Americans has gone up by like 20 or 30 years in the last century. Why? Why has the average life expectancy in the U.S. gone up by 20 or 30 years in the last century? Is it because people are legitimately living to older ages? Okay, healthcare system, modern medicine. Yeah, that's true. But what is the modern medicine and the healthcare system helping us out with? Are people actually living to older ages? And they are a little bit, but not as much as you'd think. Back in 1900, plenty of people lived to be 70 or 80 or even 90 years old. Maybe people live a little bit longer now, but what's the real reason the average life expectancy has gone way up? Once again, a little bit has to do with people living longer lives. But that's actually only, well, yeah, Jane, but specifically which people aren't dying as young? What group is not dying as young? There's one specific group. Yeah, not those with diseases. I guess what I'm getting at is, in 1900, if you were 60 years old, you were probably going to live another 10 or 15 years. In 2010, if you're 60 years old, you're probably going to live 10 or 15 more years, maybe even a little bit longer, but not 25 years longer, not 30 years longer. Why has the average life expectancy gone way up, even though who's old, how old you are when you're considered old hasn't changed nearly as much? Yeah, and not just childhood. Go even earlier. It's not just childhood. What is it? Yeah, it's basically infants. Infant mortality has gone way down. Do you guys get where I'm going with this? The reason why the average life expectancy of an American is much higher today than it was previously is because in America today, almost no infants die at a very, very young age. But in 1900, a very large percentage of infants, something like 15–20% of all infants, were going to die within the first year or so of their life. I know that sounds horrible, but so what ends up happening is if you're a 20-year-old in 1900, you're probably going to live to be 75. If you're a 20-year-old in 2011, you're probably going to live till you're 75 or maybe even 80. But it's not that big a difference. But if you're a newborn in 1900, your life expectancy is only about 45 or 50 years old because there's a decent chance you're going to die in the next couple of months from a childhood disease, from something along those lines. On the other hand, if you get through those first couple of months of life, that first year of life, you're probably going to live almost as long as somebody born today. Does everybody see how an average number like that can be affected by one little group? Okay, given what I just said, what's the answer? Yep, B is the answer. The easiest way to weaken this argument is to say the reason why dogs that are older don't have heart murmurs is because dogs with heart murmurs die. And thus, the only ones that last to age 15, oops, I'm sorry, I just crossed it out. I meant to circle it. The reason why dogs that are older than 15 don't have heart murmurs is because they've already died. All the dogs that had heart murmurs died before they got to be that old. So that would be the way to weaken the argument. So what B does is it protects against that weakness. It says that, no, it's not the case that these dogs die before they reach the age of 15. If they don't die before they reach the age of 15, then that means we're comparing similar populations. And if we're comparing similar populations, then it must be something like diet or treatment or care given to dogs. But instead, the easiest way to weaken this argument is to say, well, you know what? There's no difference in how dogs are treated. It's just that dogs that have heart murmurs die when they're very young, and they never get to be 15. It's like saying, let me give you guys another, medical related, or let's try this a slightly different way. How about this? People today who are over the age of 25 are less likely to throw a temper tantrum than a young child. Therefore, people 25 years ago were more calm and nicer. Do you guys see what I mean by that? I'm trying to state that people 25 years ago were nicer and calmer because 25-year-olds don't throw temper tantrums. But that's an absurd argument because what happens is you stop throwing temper tantrums as you get older. It's the same idea here. If all the dogs with heart murmurs die, then of course there's going to be less heart murmur dogs at age 15. The ones that should be in the population have died. They're not there anymore. Okay, how out of left field was answer choice B? Okay, answer choice B, was it very closely related to the argument, or did it seem to be something brand new that didn't make any sense the first time you read it? Yeah, exactly. The way you pick answer choice B is this. Answer choice A, cats and other pets. Who cares about cats and other pets? A is wrong. B, it's about dogs. It's about heart murmurs. Why about dying before they reach the age of 15? B doesn't make any sense to me. I'm going to keep it. C, some brands of dog foods lack essential nutrients. This only strengthens the argument if those brands of dog foods were not around 15 years ago, right? In this case, it doesn't do us any good because we don't know about the change over time. D, veterinarians are qualified to diagnose. Okay, who cares about the veterinarian's ability to diagnose? The only way this would strengthen the argument is if we had some sort of problem with diagnosis and this was correcting the problem. We don't have any change in the last 15 years where veterinarians are now able to diagnose or not able to diagnose when they used to be. And then last one, right, certain rates of illness among dogs have increased. Is that the same as heart murmurs? So Jane, I don't know the answer to that question. Are illnesses among dogs related to diet and care? Isn't it possible that the illnesses have nothing to do with the diet of the dog or how well you care for them, but they're just random illnesses that have increased because there's new bacteria or viruses in the world? E doesn't connect in any way, shape, or form to either diet and care or to heart murmurs. It's just illnesses. E is like A, cats and other pets. If E is going to be the right answer, we need to show that the illnesses are related to the diet and the care, and then that also is related to the heart murmurs. They don't do that, so E is out. A lot of times a strengthened answer on the GRE is not going to be directly strengthen the argument. It's going to protect the argument against an obvious weakness. That's what B is doing. It's not strengthening it so much as showing why a way of weakening the argument is incorrect. All right, we just ended on a really tough one, and I apologize for ending on a tough one. We're going to go ahead and just summarize what we've learned here and move on, or really take a break at this point. So the takeaways here is really to try to spend a good amount of time understanding the argument. And that means not just reading it and hoping for the best, but reading it and notating what the important parts are. Trying to think about how the parts of the argument are connected. Is this supporting the conclusion? Are these two facts connected because one of them explains the other? Is this fact in contradiction to that fact? Try to understand how the parts of the passage work together, how they fit together. That's really, really important. And then once you're able to figure that out, you can take the goal given to you in the question, and you can go ahead and anticipate the answer based on that goal. That doesn't mean you're going to get the answer predicted perfectly, but you should be able to say, oh, they're asking me to weaken it. Well, I need to find a way to attack the connection between this fact and the conclusion it supports. I need an answer that goes to that connection, right? Thinking about it like that, yeah, maybe you don't know word for word what the answer is going to be, but you can anticipate what type of answer you're looking for. Okay, questions at all? All right, guys. Well, we are going to leave this topic behind for now. I hope you guys have got a good feel for the breadth of the questions asked on the test. There's quite a lot of them. You're probably only going to see a few of them per test, though, but you want to recognize them. So when you guys are doing your homework, I want you guys to pay really close attention to exactly how they phrase the question. That's probably more important than almost anything else you do. Make sure you know what your goal is. At this point, I think that what we're going to do, what Liz and I have decided to do, is we're going to go to math next instead of the essays. And if we finish the math with some time left, we'll do the essays today. But if not, I think we're going to go ahead and do the essays next week when we have a little bit more time, just because we want to make sure you guys get the full treatment on the math for this week's topic, because it's something that really bothers people. So let's take a 5-minute break. When we come back, we will do the math and then either call it a day at that point or do the essays. But I promise you, if you don't get to the essays today, we will get to them next week for sure. So 5 minutes, and we'll dive into some math.
All right, everyone, let's get going. We need to get through math, and I think this will be a lot of fun. I actually don't think that probability and combinatorics are all that terrible. I really think it's in how you think about these problems, how you sort of set them out in your mind. But quick question, how many of you have ever solved probability problems? If you remember, from many people do it in algebra class, or you could have taken an actual class if you took stats. They often start with probability. Yes, smile at me if you've done probability. If you know how to calculate, you know, if I flip a coin twice, what are the odds that I get heads, heads? So everybody has. So let's just start them, okay? And don't be psyched out by this. I am going to show you a few tricks for solving them quickly, but these are fun, okay? So here you go. I'm going to turn chat to moderator and just chat to me what the answer should be. All right, we're just going to dive right in because I don't believe these are that bad. Here you go. All right, so let me just show you quickly how to solve. I got 2 correct answers, which was awesome. I just want to show you a quick little technique for solving. Now, who solved with a probability tree? Smile at me if you knew how to use a probability tree, because it's just the most amazing tool. Okay, so Jignasha got a little stuck with that probability tree. All right, so it's amazing if you know exactly how to use it. It's not so amazing if you can't remember. All right, so let me just write it out for this. You think about this, okay, a number cube with sides labeled 1 through 6 is rolled twice. If there's an equal probability of landing on any of the 6 sides, what is the probability that the cube lands on an even number than an odd number? Okay, so I draw what I think of. This is a probability tree. So here's my first roll, all right, and this here, let me highlight it in yellow, represents a chance event. Okay, I roll, that's chance. And then I have 2 possible outcomes, E and O, even and odd. All right, and Jignasha, since you struggled, what's my probability on that first roll of getting an even? Think through it with me now. What's my probability of getting an even? Okay, yeah, let me turn the chat back. Okay, and you wrote 3/6. It's absolutely correct. There are 3 even numbers out of 6. You could write 1/2 as well. Okay, so I want to know, all right, so after I get the even, here's my second roll. Okay, and again, there's a chance event, right? It's right here. Either, you know, I rolled an even and then I either get an even or an odd. You know, it's not that exciting of a probability tree. Or I rolled an odd and I would get an even or an odd. Now, what's my probability on that second roll of getting an odd? Anybody? Even if I got an even on the first roll, doesn't matter. What's my probability? All right, yeah, no, it's 1/2. It's the same. Okay, so you guys are not going to fall for slimy Vegas tricks. Ever heard, sometimes it's in movies, maybe I can tell you that I was a math major and we once took a field trip to a casino, but people would say, oh, you know, too many evens have come up and odd is going to come up. No, they didn't understand probability. We know that we have independent probabilities, okay? Every time I roll, it's going to be 1/2, and that's what mathematicians mean when they say, oh, it's independent. The last one doesn't, there's no effect. Okay, so my odds are always 1/2. Okay, so there are 4 possible outcomes. I could get even, 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 odd, odd, even, or odd, odd. But this is the GRE. I have time pressure. What's the only thing that I care about? What's the only outcome that I care about? Right? It's even, odd. Okay? So to figure that out, I just follow the path through the probability tree. All right, and those of you, smile if you've seen this probability tree before. What do you do as you travel along the branch of the probability tree to calculate? I want to calculate even then odd. What should I do? All right, what should I do? Oh, somebody must remember. What do you do when you travel along the branch? You multiply. Thank you for saving us, Caitlin. All right, so the probability here is 1/4, and that was the correct answer. But say I asked you for the probability of getting either even odd or odd even, and this is for you, Jignasha. What should I do? What should I do? This, by the way, is also 1/4, and this is 1/4. What is the probability of getting either even odd or odd even? I don't multiply, okay? I don't multiply there. Here I'm going to add, okay? Here I'm going to add. Now think about it. I know the probability of getting even and odd is 1/4, so the probability of getting odd and even is also 1/4, so the probability of getting either of those has to be greater than 1/4. It's actually 1/4 plus 1/4, okay? That's how we think about it. The total probability has to sum to 1 at every level of the probability tree, right? A probability has got to be a number between 0 and 1. 0 means it doesn't happen, it can never happen, and 1 means it always happens, okay? So we're always going to think about probability that way. Another way you can, so this is where, how many of you just multiplied? You multiplied 1/2 by 1/2. You didn't even have to use the tree for this one because it's so small. Who just multiplied? Smile at me if you just multiplied. All right, great. And it's a shortcut to just multiply. If you're struggling, the tree is really helpful, but the only part of the tree you need, okay, is the section of the tree showing the desired outcomes. All right? There are a bunch of ways to think about probability. I happen to think this tree lays it out and makes it straightforward. As I travel along the branch, I multiply because, well, first I have to get an even. There's only 50% chance of that. Then I have to get an odd. Well, there's only 50% chance of that. It doesn't matter that I just got an even, right? So I have to multiply the two, and oh my goodness, then I have a small probability. Okay, because there are 4 possibilities. I could have gotten even, 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 odd, odd, even, or odd, odd. All right? Jignasha, how are you now? Comfortable with this? Or ask me a question, please. Okay, so this is so cool. On the GRE, the probability trees are not that big. And you don't need to draw the whole one. If you get confused, all right, you just need to draw out the probability tree, the part that you care about. We call it a pruned probability tree. So here, all I would draw, all right, okay, so first roll, even or odd, I don't care about odd. Second roll, even or odd, I just care about odd. That's plenty, and then you can calculate it. So it doesn't even have to take much time. All right, and after a while, you'll start to take the shortcuts and just multiply, okay? So let's try another problem. This time, it's a QC. You can use the same method, though, and it can be really fast. All right, I'm going to put up the timer for 1 minute and 15, and let's see, let me pull up. We've got our polling. Okay, let me set polling to A through D, and let's just try this next one as well. Okay. All right, take it away, guys. Okay, all right. Now, I've drawn this little tree here. Why did I draw it this way? Anybody tell me? Okay, why did I draw this? Why did I draw this? What does this represent? Okay, coin flips 3 times. All right, so what are the probabilities that I need to plug into the tree, Jignasha? What are my odds of getting ahead? on that first flip? A half. Okay. A half on the second flip and a half on the third flip, right? How do we combine them then, and why? How should we combine them? Multiply. Okay. So 1/2 times 1/2. All right, so I've got 1 times 1 times 1. All right, so that's going to be 1/8, right? Okay. All right. So what's the answer? What's the answer? Awesome. Everybody has it. Okay. For some of us, these are too easy, and I've got a more challenging one next. Okay. If it wasn't too easy, don't worry about it. You can do the more challenging one. You just may need to write out the tree rather than just doing it with the fractions. Take your time. If you're getting them wrong, the tree can be written out in about 30 seconds. It's not that hard to write out the tree. It's not that time consuming. Many people are reluctant and try to do it in their heads, but that might not be the best approach. Okay, so let's try another one. A little harder, a little more fun, but totally doable with that tree. Okay, even if you do not know how to just write out, take the shortcut. Okay, this one was more challenging. All right, I have only one correct answer. Jane, congratulations. Help us out with figuring out the math. I will even draw in the tree. All right. Okay. And help us figure out the math. All right, first thing, I pull my first jelly bean, first jelly, and then second jelly. And even though it says he pulls out two, it's one after another, right? There's got to be a moment between them. Okay, so first and then second. The first pull, the probability is 1/2. Exactly. He's got 6 red and 6 blacks. So it's 6 out of 12 are going to be red, which is just 1/2. Fantastic. Okay. Now, thinking about that second pull, we want the probability of both being red. All right. Then if you pull, now this is the subtlety. Everybody read what Jane wrote. 5/11, and Jignasha's got it as well. If you pull a red jelly bean, there'll be 5 red left in the bag out of 11 total. Exactly. This is where this problem is different from the coin. Once I've taken one red out, my odds actually change. Things are different now. It's only 5/11. Okay? So going along that probability path, I want the path to red, red. All right? And I'm going to say, well, I got 1/2 for the first red. I multiply, and then I got 5/11 for the second red. Okay, so I got 5/22, and C is correct. Questions, questions. Click to the C if you get it. Otherwise, let me know. Ask me a question if you wonder, how did I do this? Or was there another method? Okay, so everybody has gotten it. Fantastic. This, I think, is about as hard as I've ever seen a GRE probability question get. You really can work them out. Okay, now I'm going to show you another one. It's not that the math on this next one is hard, it's the wording. Think really hard about what it means. And they talk about one event and then another, and you might even want to label them, first event, second event, to help you draw your tree. Okay, this next one is just about confusing wording. All right, so let's pop this one up, and of course it's a QC since it's about confusing wording. And let's try this fun little problem. Okay, now we have some confusion on this one, all right? So when I draw out my tree, okay, events A and B have an equal probability of occurring. The first thing that I should think about is what? What are the two branches? What are the two branches, guys? Type it, message it to me. They're probabilities, but what are they? What's the event? I could call it the first pole, or I could call it A and not A, okay? It's not A or B, right? It's A and not A. Either A occurs or A does not occur, okay? And you took the example of a coin, okay? But yeah, you could say there, you know, A could be the first flip, head or tails, B could be the second flip, all right? So when you think about it, you've got A, not A, and then out here, your second thing would be B or not B, okay? B or not B, all right? And we're trying to compare two paths, the probability that A will occur and B will not, versus the probability that both A and B occur, okay? So what do we know? All right. Do we know the probability of A? What do we know? Do we know the probability of A? Events A and B have an equal probability of occurring. No. All right. So I'm going to call the probability of A, I can be confusing and mathematician-like and put a little a. Okay. Does that make sense? I could put an X, but how about I call this just PA? All right. Does that make sense to everybody, or is that too confusing? Just there's some probability. I don't know what it is. The probability. Smile if that's okay. Or I can just do it without the notation and just call it A. Okay, so everybody's okay with that. All right. Now, what else do I know? What about the probability of B? Do I know that? No, I don't. Okay. So what do I know, though, in my given information? It's the same as A. Excellent. Okay. So PA equals PB. All right. So this is PA as well. All right. What's the probability of not B equal to? What's the probability of not B have to be equal to? All right. If the probability of B is A, what's the probability of not B? It would be, yeah, Jane has it. It would be 1 minus A, and Ignatia, 1 minus, all right? 1 minus the probability of A. Okay, so then when I multiply, I'm comparing A squared, which is the probability of that both will occur, all right? This is A squared, right? It's A times A. And I'm comparing that to A times 1 minus A. All right? So that's A minus, let's multiply it out, A minus A squared. Okay? Now, which is greater? Do we know which is greater, A or 1 minus A? Can we tell? Do we know which is greater? You can't say. Exactly. You really can't say. I know it's a fraction. I know it's between 0 and 1, all right? I know that 0 is less than A is less than 1, or less than or equal to. Okay. But I really can't say what's greater, 1 minus A or A, right? I don't know. Is it less than a half or more than a half, right? And that's the trickiness of this question, okay? It looks like it should be even. It looks like I should multiply it out, but that's only if I'm thinking of coins, where 1 minus A would be the same, all right, as A. You know, the odds of a head are the same as a tail. But this is something different. I mean, A could be 0.8, A could be 0.2. I really don't know. It doesn't tell me. All right, and you have to be careful of this with the wording. You have to think, what do I know and what do I not know? Questions. Anyone have a question? This is a subtle one. All right, smile if this is, no, actually, now it's fine, especially if you got it wrong. Let me know if it's fine. Otherwise, let me know if you have a question. Okay, it's this whole thing. You can't tell which is greater, A or not A. Or A or 1 minus A. All right, nobody's smiling, nobody's typing. So please, if it makes sense, smile at me. If it doesn't, please ask a question. All right. Okay, everybody's smiling, all right, and I see one person typing. So I'll wait for the person to finish. Okay. Is there an alternate method to the tree? Absolutely, Caitlin. There are definitely alternate methods. What most people like to do after you really figure out if a problem is easy for you, okay, and many people after a little practice will find something like this coin problem easy. You just write out as a fraction problem the probability at each stage. Okay, and that works best for this type of problem where it's a coin, it's the same probability of heads as tails, it's pretty simple. For something that's a little harder like this, generally people are much more accurate if they use the tree. All right, and for something like this, it can help you catch yourself, you know, as you think about it. But again, you could have just written this one out and then reasoned about this, trying different probabilities for A to figure out which was greater. Okay. What do you think of the tree? Are you not so happy with the tree? Not so sure? I generally find that, and I'll wait for Caitlin to finish typing, I use the tree for the hard ones, but now that I've practiced, okay, I usually write it out with the fractions. You're a little confused by it? Okay. Okay, let's go back. This problem is really, you just need some practice. Yeah, try with one that's really easy for you where you would normally use a fraction, all right, at first, and use the tree to think about, okay, so what happens? You know, think of each one of these as an event, a random event occurs, okay, a flip. So what are my possible outcomes? All right, and count them out. The trees can also be used for combinatorics, which is what we're doing next for counting things. And there you count possibilities. Okay, so if I say, for example, asked you about how many outcomes, this is something really cool with the trees. If I said if I flip once, how many possible outcomes are there? There are 2, right? There are only 2 branches here. But if I flip twice, how many different outcomes are there, guys? How many different outcomes? Just looking at the tree. If I flip twice, how many possibilities? Look at it and tell me how many possible outcomes. If I flip twice, in terms of head, 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 tail, tail, head, tail, tail, how many outcomes are there? All right. I'm going to help. Maybe I'm confusing you guys. There are 4 possible outcomes, okay, at this level. Jane has it, okay? There are 4 outcomes here. At the second level, when I flip twice, and at each level, if I flip the 3rd time, okay, think about it. How many outcomes would there be? I just sketched them in. If I flip a 3rd time, there are 8, okay? The tree is really helpful for that so that you can list them out in your head. Usually the GRE problems are small enough that you could actually write out all the possible outcomes. All right? And Caitlin, that's a really good thing to practice to see why the tree works. All right? To think about all of the possible outcomes from flipping. Okay? Does that make any more sense now, thinking about it as possibilities? Okay. All right. Good. Now, this stuff is really useful when you have to count out possibilities. All right. There are other ways to do it as well, but it's a very similar methodology for some of the combinatorics. All right, so we're going to try, I have a whole bunch of combinatorics problems, but why don't we just try one to start with? Let me go and grab it. And we're just going to treat it as a getting to know combinatorics problem, okay, just to see how they work. So why don't you guys try this? Look at what it is. My hint is that the tree is helpful here too, but it's not probabilities, it's how many outcomes do you have, how many possibilities. And we'll work on this. You know, why don't you guys just try this one and then we'll work on it afterwards. Don't worry if you don't know how to do it. See then, if you don't know how to do it, how you could rule out answer choices. We'll talk about the methodology after we try it. So Jane got it, and Jane used the tree, okay? Really, these questions have a reputation as hard, but they're not that hard if you think about what's happening, if you sort of break it down into each stage. Jane, are you able to get on the mic? Just let me know, either way. Otherwise, I'm going to have you just guide me. Okay, Jane, I would love it if you would tell us how you thought through this problem. I'm very impressed that you got this first one. Fantastic, with no pre-guidance.
Okay, so I used the tree on this one, and I just started with 4 kind of branches, I guess, and I labeled them each P1, five branches because there are 5 pairs of pants, and just labeled them P1, P2, P3, P4, and P5. And then off of each one of those, I did 4 additional branches for each of the 4 shirts that can go with each one of the pairs of pants. And again, just labeled them S1 through S4. And then off of those 4 branches, I just did 3 branches for hats. And I didn't really take the time to label all of them. And I actually didn't even end up drawing them all out because it was taking a long time, but I just kind of counted up by 3s for each of the shirt branches, if that makes sense, and got 60.
Okay, now that's perfect, all right, and that's absolutely how to do it the first time, all right, to see why it works. On his first reach into his drawer, say he reaches into his pants drawer, he's wearing one of each, he has 5 pairs of pants to choose from, so there are 5 options. Okay, and then exactly as Jane said with shirts, and I'm going to label some of them, S3, S4, you can see that he has 4 shirts that could go with each pair of pants. And then for each pant and shirt combination, he has 3 hat combinations. Okay, now this would be horrendous to draw the whole thing, but you can see that if you did, you would end up with 60 branches at the end, okay? And you would end up with 60 branches because you have to multiply. You think about it, okay, pants, all right, I pick a pair of pants, and there are 5 of them. How many branches, then I pick a shirt, okay, and there are 4 of them. So how many combinations of pants and shirts could I make? All right, just drawing this in, you know, for each of these 5 pant branches, I have 4 shirt branches. So that's 4 times 5, that's 20, okay? And then the same thing with the hats, all right? So I've come up with 20 pants and shirt combinations, and then there are 3 possibilities for the hats. So I multiply again, all right? So this tree, although I would never, never want to write this one out, this is horrendous, leads me to how to think about this. I have to multiply the number of options, okay? This is a classic counting problem. And you could use a tree, you know, it gets really awkward, but if you had a big enough piece of paper, but really the tree lets you know why it has to work this way. Oh, okay, for each pant and shirt combination, I have 3 hats. So how many pant and shirt combinations? Oh, 20, okay? Questions or comments? All right, smile if it is clear now, but let's talk about it otherwise. Okay? All right, I've got 2 smileys and 1 person. Oh, awesome! Awesome! Fantastic, guys. All right, now, these are just not that bad. Once you know how to think about it and lay it out, they're just not that bad, okay? Despite what people may say about this type of problem. So I have a couple more. We're not going to do a ton more because I want to show you another variant on this. And let's see, I have written all over my slide. So what am I going to do? You multiply by 3 and thought that's too simple. It is simple. These are cool problems. They're just not that hard. I mean, you have to think what's going on, but they're not that bad, Jignasha. They have too bad of a reputation for what they really are. Okay? It just means you have to sit and think out what's going on. And then the math, just multiplication, it's not that hard. All right. So now I'm going to erase all this mess. Oh, my goodness. Okay, so you can read this next problem, and we're going to try the next one. And everyone, okay, try this and use the shortcut method. Okay, try this one. We should all be able to handle the shortcut without a problem. Okay, now, Caitlin, Caitlin got this quickly. How did you think through this? This is a little tricky to think out how to lay it out using the shortcut method, but it's absolutely doable. Caitlin, why don't you take the mic and tell us how? Okay, you did it with the tree. That's fine. Tell us how you did it.
Well, I just set up the tree, so I did an A, B, and C line, and then from each of those I did whichever one wasn't on there, and then added all that up, and that was 6. And then I wasn't entirely sure, so then I wrote it all out, the BCA, BAC, all the different combinations in my head.
Oh, I love that, writing out the possible combinations. That works for this sort of a problem because it's not very big. If you think about it, we have parent, we have child A, and we have child B and child C. Okay, I know that parent always goes first, so I just have to think about what the possible orders are for the children. All right, I love what you did. Okay, I'm going to add to it. All right, I'm going to show you how to take a shortcut here, and then there's B, A, C, okay, and then C, B, A, and C, A, B. Okay, so you realize there's 6 possibilities. Okay, and you could have written it out. I take it you did the tree as well, where you said, okay, so the first kid's either A, B, or C. All right, then there are 2 options on the second kid. Okay, and then the third kid could only be, there's only 1 possibility. Okay, that's another way to do it, and just say, okay, so there's 6 possibilities. All right, the shortcut here, okay, we're going to think about it. I'm putting 4 people in a line. How many choices do I have for the first person? This is a dumb question, right? It has to be the parent. 1. Okay, Jignasha, now that I've taken away the parent, how many choices do I have for the second person in the line? How many choices for the second person? 2. Well, actually, wait a second. Not 2. 3, right? 3 choices for the second person because I've got 3 children. Now, once I've pulled one of the children aside, and how many choices do I have for the second child? I pulled the parent, I pulled the mom and 1 child aside, and this is meaningful to me. I have 3 children. Okay, how many choices for the next child? How many options? 2. Exactly. And then the last one, there's only 1 left. So look at this. Again, I'm just multiplying. All right? I'm just multiplying. Just as I would, you know, it relates back to counting them out or following the branches. But again, the shortcut works really well. You just think, how many options at each stage? And like the problem with the jelly beans, the number changes because once you pull a child out and into order, you have fewer children remaining to pull from. Okay? Smile if that answer makes sense, if you understand this problem. All right, otherwise ask me a question. Everybody's good with this? Okay, so we're going to do one more like this. And this time I'm going to be more clever about getting rid of these things before I show it to you. All right. And then I'm going to try another, we're going to try an advanced topic, which I think you guys will enjoy. We're doing really well and seeing that, you know, I actually love this stuff. I think this is some of the most fun math on the GRE. It's not as much work as some of the other math. You just need to have a good method. All right, so let's try this one. All right, so let's look at how to do this one, okay? So a company creates a 3-digit passcode. Who used the shortcut for this? That cannot begin with 0. Smile if you used the shortcut. Thinking about this. Okay, so let's write it out. With the shortcut, we have to think about how many there were at each step. All right, the company creates a 3-digit passcode that cannot begin with 0. 3 digits. How many possibilities do I have for that first option? How many possibilities? 9, exactly. I can't pick 9. Now, for the second digit, how many possibilities? I can't pick 0 for the first. How about for the second digit? 10, exactly. What about for the third digit? Now, this is where you have to be careful with language. Yes, Jane has it, Caitlin has it, it's still 10. This is the key, because nowhere did they say you couldn't repeat, all right? Nowhere did they say you couldn't repeat, okay? So the answer has to be E. Questions about that, especially if that was a struggle. Questions or comments? Who got stuck on that last one? Anybody just looking at this going, I don't know. Yeah. All right. Now, unless they say no repetition, no duplicates, think about how many choices. With the children, we know children are different than digits. Once I put a child in line, I don't have a duplicate, right, of that child. That child is already in line. But if I'm just creating a passcode with digits, I mean 0, 0, 0 is, well, not here because I can't start with 0, but 1, 0, 0 is fine, or 1, 1, 1 is fine. Okay? Sometimes they'll tell you you won't duplicate, and other times you have to consciously ask yourself, can I, it's like the problem with the jelly beans. Once you've drawn a jelly bean, it's gone. The children are like the jelly beans, but this is more like coin flips. Once you picked a digit, you can pick the same digit again. All right? Okay? Does that make sense now? Smile at me if this makes sense. If it does, I want to move on. Okay, good. All right, now I have a more challenging type. Who has done before the types of combinations, they're called combinations, when you figure out how many groups of size whatever can you get from something? Like if I have 6 pots, how many groups of 3 pots can I make? All right, Jignash has done it. Jane, Caitlin, have you done that before? Don't remember it very well. All right, not sure if you've done it. All right, I could put the problem up and let you try, okay? Or we could work through it. The key with this type of problem, all right, is really thinking how many choices, how many options do I really have, okay? Why don't I put it up? We'll try it. And if we get stuck, since we don't have a lot of experience with it, we will work through it together. Now this problem I can see was a real struggle, all right? Let's see how far we got in thinking it out. How many people wrote out 5 little spaces thinking a coach is going to select 5 players from a group of 9, so I've got 5 slots on my team? Who got that far? Smile at me if you got that far. 5 slots on my team, right? Okay. Now, let's just think through it. It looks intimidating, but it's not that bad. How many choices does the coach have for the first player? How many choices does the coach have? 9, right? Thank you, Jane. And the second? How many choices for the second player? Once I've chosen a player. Yeah, players are like children. They're people. I pull them aside. I no longer have 9. The third player? 7, right? Okay, so this part's not so bad. Okay, how many of you got this far? How many of you got this far? Okay, so everybody got this far. Now, but there's a problem. This is not the solution, okay? And you could use your calculator, but it's still not the solution. Huge number. Why is this not the solution? What's the problem with this solution? Say I've numbered my basketball players. I put numbers on their jerseys. Why is this not the solution? All right. It's not 9 times 8 times 7 times 6 times 5. Why can't this be the solution? It's important to know this would be the number of different orders. There can't be, okay, it's not repetition. Caitlin, I think you're thinking about how many teams are possible. Yeah, how many teams? Okay, so if the players' numbers, say, were 9, 8, 7, 6, and 5, in a different arrangement, it would still be the same team. I have repetition here. I have repetition. How do I reduce that repetition? Who is thinking about that? I have repetition. Who is thinking about that? Let me know. Smile at me if that was bugging you. All right, no one's smiling. It would be really good to be bothered by that, to say, wait a second, I have repetition. Okay, see, I could have all these different teams. It could be, you know, I could have pulled 9, 8, 7, 6, and 5. All right, you're bothered by repetition. Or I could have pulled them in this order. I could have pulled, you know, 8, 9, 6, 7, and 5. And they'd be the same team. So how many duplicates are there? Okay, these are called duplicates. This would give me the number of what's called permutations, but I need combinations. I need the number of distinct groups, not the number of orders. So how many ways? Say I picked 5 players. How many ways are there to order 5 players? Okay, if I have 5 players, how many orders can I put them in? What if I just had 5? How many orders could they be in? How many orders? Think about it. 5 possibilities for the first one, 4 possibilities for the second, 3 for the third, 2 for the fourth, and then 1. So this is how many duplicates I have. All right? So what I have to do to answer the question, I'm going to divide. I take my 9 times 8 okay, times 7 times 6 times 5, all right, and I divide it by the number of duplicates that I have, okay, and I have 5 times 4 times 3 times 2 times 1 duplicates. That many possible orderings. Are you with me so far? Smile if you're with me so far. If you're not with me, ask me a question. Okay, so this is where it gets cool. I don't have to plug the monstrosity into my calculator because I can do a lot of canceling first. And with this type of problem, there's always a lot of canceling. 4 times 2 is 8. Out goes the 8. All right. 3, cancel that with 6, and I'm left with a 2. Okay. So then I get this whole thing is going to be equal to 9 times 7 times 2. Okay, that's not so bad. 9 times 7, we know our times table, that's 63. Or this you could plug into the calculator. 63 times 2, and you're going to end up with 126. All right. Okay, this is dividing out the duplicates. The number of duplicates. Okay, so there's a formula, and I'm going to give you the formula, but I want to show you how it works. So often people memorize a formula and then under the pressure of the test, forget it, okay, and have no idea of what they're doing. And if you know why it works, you have a better chance of remembering it, okay? You're dividing out duplicates when you're doing this, all right? Okay, does it make sense what we're doing? Smile if it makes sense what I just did, that I listed all the different ways to list them out, and I said, okay, so how many ways? Yeah. Okay, good. Now, Manhattan has a great formula for this, okay, and what you do is you take the number in the pool, factorial. Everybody remember factorial? Okay, and you divide by the number in the pool, the in group, or the people who are going to be, yeah, in factorial, in, out factorial, okay? 5 people are chosen, so 5 people are in, 4 people are out. This is the formula, all right? We did the same thing, okay? Mathematically, we did the same thing if you wrote it out, but we really thought about the logic and how it works rather than just, oh, here's the magic formula. All right, this is the formula. It will work. 9 factorial, the way it works, you can see this because you cancel that 9 factorial with a 4 factorial. Okay, and you're left with 9 times 8 times 7 times 6 times 5, 2, 1. And once you cancel out the 4 factorial, it's just over 5 factorial, right? So it's going to be the same. It's just, this is the handy-dandy formula. When you learned it in school, it's taught in an almost incomprehensible way. All right, Jignasha, you may remember it. Most people forget it because it's taught in such a confusing way. You get this thing, n choose k, right? You may have seen this. Okay, and it's given as n factorial over k factorial and minus k factorial. All right, so if you don't remember this, you're in good company. Most people don't remember this. Okay, now the key is, did it make sense the way we did it? All right, any questions about this? Okay. If not, ask away, all right, before we go on. These are the hardest combinatorics problems there are on the GRE. You could skip them, and it wouldn't make any difference to your score. You will only get them in your hardest second math section, and you will not get very many, maybe 1. All right? But it's good to know how to solve, because I'm expecting you guys to all do fabulously. All right, smile if you're comfortable now. You can do it with a formula. I am totally fine with you doing it with a formula. The size of the pool, that's 9 people, you know, and then we're going to pick 5. That means 5 are on the team, and there are 4 left out. Okay, you can do that, or you can just think it out this way with the slots, just like you did all the other ones. Okay, thinking, okay, so how many ways are there to choose these 5 people? But they're duplicates because I don't care about orders, so I have to divide out the number of duplicates. All right, awesome. Absolutely awesome. I have one little combinatorics problem left for you, and I don't want anyone to be intimidated by it. I actually think it's easier in some ways than what we just did, but you're going to have to use this technique. All right, I think you're going to have to use this technique to solve. Okay, let us take a shot at this next problem. Here we go. All right, so we struggled a little bit with this one. Sorry, I had my mic off for a moment. It's a little bit challenging at first to see what to do. Okay, and so it took, we don't all have answers in it, so this took a little longer. How would you approach this strategically? The club's membership has 7 sophomores, 5 juniors, and 4 seniors. We know about this delegation, 1 sophomore, 2 juniors, and 2 seniors. How should we approach this? Oh my goodness. 1 sophomore, 2 juniors, 2 seniors, what should we do? Anybody? Type in, tell me if you got it. Tell me what was your strategy. How do we solve? How do we think to begin? You split it up by class. I like what Jane is saying. Jignasha permutation. Okay. More details. Jane, help me out with split it up by class. What were you thinking? Are you meaning that first you figured out the problem, you split it into 3 mini problems? How many ways to get 1 sophomore, how many ways to get 2 juniors, and how many ways to get 2 seniors? Okay, so let's think. All right, but let's, all right. Okay. You did 7 factorial over 1 factorial. Okay. And then for the other classes, all right, yeah, okay, yeah, so you broke it out each way. You used the formula, all right? So this is your strategy. You said how many ways to pick. First you said sophomore. Yeah, perfect, perfect. 1 soph, okay, 2 June, 2 seen. Okay, and then you multiply, right? Yeah. Okay, so formulaically you got it, the 7 factorial over 1 factorial times 6 factorial using the formula, or you could just say, well, if I have 7 sophomores, how many ways are there to pick one of them? There's 7, but the formula works perfectly. If I have 2 juniors, absolutely, you can use the formula, 2 factorial over, sorry, 5 factorial over 2 factorial, 3 factorial. Okay, and that simplifies out to 5 times 4 over 2, all right, which is just 10. Okay. 10 of them, right? And then the same thing, and then, oh, okay, so for the 2 seniors, same basic idea. Yeah, you did the 4 factorial over 2 factorial, 2 factorial, which is going to give you how many? Guys, how many? 4 factorial divided by 2 factorial times 2 factorial is what? What is that? Just write it out. Yeah, it's 6. Okay, and never don't. You can type this in. You can multiply on your calculator, but because you don't have a factorial button, it's going to be so much faster if you simplify on your paper first. Okay, so this is 6, because you just cancel out the 4s. All right, and then you multiply, okay? Because I want to pick, I have 3 slots, right? I'm picking, you know, I have the sophomores, the juniors, and the seniors. It's a double slot for juniors and seniors, but I don't care which order they come in. I've got 7 of these guys, 7 ways to choose this person, 10 ways to choose these 2 people, and 6 ways to choose this person. All right? So I end up with 420. Okay? So the answer is A. All right? Questions. Questions. Okay, see how we just combined our techniques using the same techniques in different combinations. And what Jane did, which was so clever, was to break down the problem into littler pieces. All right, which is the key to the very hardest problems. You have to break them down. Questions. Ask or smile. Smile if you've got it. Ask me a question if you don't see it. All right, if you're struggling a little. Okay, we are doing just an amazing job on these problems. Absolutely awesome. And I'm going to just swipe the end of our time, though. I want to do one more problem with you guys. You guys are really rocking the probability and combinatorics. I hope that this is not as intimidating as it looks. All right. We are going to do an overlapping sets problem, okay? And since we're only going to do one, I'm going to tell you draw it out. How many of you have done overlapping sets? Smile at me if you remember doing the set problems. You may have used Venn diagrams. That's the most popular way to teach it in school. There's a formula, but I always forget the formula. Okay, Jignasha, you did it. All right, so Jane, you don't remember? I'm going to put the problem up. Give it a good try, okay? Caitlin and Jane, give it a good try. If you don't remember, no worries. I usually go through this problem, okay? So we're just going to go through it and see how to solve it. But give it a good try first, all right? It may come back to you. Okay, and I'll turn chat to private so everybody can message me with the answer since there are multiple answers. All right, now, okay, I got some correct answers here. I'm really quite delighted. All right, let's see. I am going to ask Caitlin to hop on the mic. Caitlin made a realization while she was solving and changed her answer. Caitlin, tell us how to think about it and tell us about the trap that you just skirted away from.
Well, the traps I solved for was I originally put down 0, 11, and 50, which is not right. It can't be 0 because 251 plus 156 is more than 400. So there has to be at least seven students that are overlapping and taking both algebra and Spanish for there to be 400 students in the school. And then you know that it can't be 157 or 251 because there's only 156 students taking Spanish.
Okay, that was beautiful. Absolutely beautiful. All right, I love the way you reasoned through that. Okay, absolutely wonderful. All right, now thinking about it formally, how to attack it. All right, this is very much about sets, and there are two competing diagrams that are really helpful with this. One is the really familiar Venn diagram. Smile at me if you remember a Venn diagram. Smile at me, okay? So outside we have neither. All right. And then inside we have overlap. Okay. And then on this and here is going to be algebra. And this is Spanish. And this is Spanish. Okay. So what we know when we think about it, all right, there are 400 students. 251 take algebra. Okay, so this is 251 total. And with Spanish, 156 take Spanish. So if I call this region A, this is B, and this is C, okay, I could say, all right, so, 251 is going to be A plus C, and 156 is going to be B plus C, okay. So if I add them together, 407 has to be A plus B plus 2C. Now that's very mathematical, very formal. Not everyone likes that, but you do see, okay, there can't be more than 400 in this total diagram, the Venn diagram, which I used to call a MasterCard diagram, total in picture. All right. There is another way to do it. You can set it up. There's a method invented by Lewis Carroll, the guy who wrote Alice in Wonderland. How many of you knew that guy was a mathematician? Anybody know the guy who wrote Alice in Wonderland was a mathematician? No? Okay, so new factoid. All right, so he was a very famous mathematician, and he loved this type of problem, and he came up with another way to solve them. All right, so here you would write algebra, no algebra. Okay. And here you would write Spanish. No Spanish. Okay, it's nerd humor. You guys have to tolerate us. Ian and I are nerds. Okay. And then you might think about it this way. You could think about the total. And the diagrams are just to help you. This problem is very straightforward. They tend to be, this type of problem tends to be pretty straightforward on the GRE. Occasionally you get a hard one and you might want the diagram. For the diagram, you would write in 400 as the total. You know there's nobody under 0, okay? And then you know that you've got 251 taking algebra and 156 taking Spanish. All right, so you realize, oh, okay, what's the maximum who could be here? All right. The magic thing about this diagram is that this thing and this thing have to sum to 156, right? Spanish has to be Spanish with algebra and Spanish without, okay? And the total on algebra has to be Spanish, no Spanish, okay? And we can just figure out what the other numbers are by subtraction. So 400 minus 156 is going to give us 244. 400 minus 251, we'll have 149. Okay, and then you could actually work it out. Okay, so what number has to go in this box up here, guys? What number has to go in this box? Yeah, 149. Okay, and you would just think this out. They have to sum. Sorry, oh, let me turn chat back on. Okay, and you could think it out. All right, and figure it out this way and realize that you have to have at least 7 in the overlap. You could have more, okay? I don't care how you think about it. There are many different ways to think about it. You can read through them in the book. I think for the GRE, this is going to be sufficient, okay? Just wanted to show you some different ways to think about it if you got stuck with one of these. But you could use a chart thinking how many are where, okay? Smile at me if at least one of these methods made sense. Probably the simplest is what Caitlin did. All right? Otherwise, let me know with a Pepto-Bismol face or something if you're stuck. This is our last question, so I'm perfectly happy to answer questions about it. Everybody okay? All right. If not, ask me a question. I think we are all done with class. Ian, let me just pass the mic to you because I am done with math.
All right. Well, I think we're done with class then. Wonderful. So we didn't get a chance to do the essays today, but don't stress about that at all. We will open up with them next week. In the meantime, you guys have a great week. As always, happy to stick around for a little bit after class if anybody has any questions. And hopefully you guys have feeling good about all the good stuff we covered today. So we'll see you next week.